Hi everybody, welcome to physics teacher classes. So we are discussing kinematics. In this kinematics we are going to discuss graphs. Already we learned a few things regarding these graphs. Yes, that is in part 1. So before going to start my class, my humble request is please subscribe my channel and share it to your friends so that we can reach to all members of the society of physics. Okay, thank you very much. Today we are going to discuss some more things about graphs. So yesterday we learned some basic terms regarding graphs. So here let us see one problem here. How to solve it? Let us see here. Okay, so there is a graph, that is a VT graph is given, for example. In an examination, there is a question, velocity time graph is given. So this velocity time graph, velocity is in meters per second and time in seconds is given. And the graph looks like here. The shape of the graph is this. This is the graph. Okay. Now this is 0 and this value is 10 and somewhere this value is 5 and this is 2 meters per second and this value is 8 meters per second. Okay, this is the graph. From this graph what we need to calculate is first one is the acceleration. First one is acceleration we need to calculate. Okay, no. And second one is distance traveled. What is that? Distance traveled from 0 to 10 seconds. 0 to 10 seconds. And the third thing is displacement. What is that? Displacement in that also 0 to 10 seconds. These are the things we need to calculate from this given graph. Okay, now let us listen carefully. So first we need to calculate acceleration. So it is a velocity time graph. How do you calculate acceleration? Should we calculate area or slope? Which gives acceleration? Slope of velocity time graph gives acceleration. That we learnt already. Okay, slope of VT graph gives acceleration, right? Now slope, we need to calculate slope. Slope is nothing but what? y2 minus y1 by x2 minus x1. Already we learned this. Now this is equal to, okay, so y2 means how much? On y-axis, what is the y2 value? 8. Yes or no? Minus y1 is 2 divided by x2 on x-axis, what is the final? 10 minus x1 is 0. So how much is this, Nana? 6 by 10, that is equal to 0.6 meter per second square is the acceleration of the body. Clear? Okay, first one is completed. Now let us calculate second thing. What is that? Distance in 0 to 10 seconds. Okay, distance. How would I get a distance? Very good. Area of VT graph gives distance. Yes or no? Now here so many questions will arise here. So should I calculate area up to this part? This is the area because graph is starting here. Or should I calculate this also? Should I calculate total or up to this? Okay, so listen carefully. So area means it up to time axis. This total area you need to calculate. Okay, no need to get any confusion, any doubt. Up to time axis you shade the area. You shade that totally. Okay, not up to, because graph is starting here up to this, it's not. Okay, till time axis. Now listen carefully here. So here two parts are there. This is one rectangle and this is one triangle. Yes, no? So this is area of a rectangle plus area of triangle. Now area of rectangle, how to calculate? We know that length into breadth. Okay, yeah, that is equal to, what is the length? 10 minus 0, 10 into breadth means height, that is 2. Okay, plus this is the area of this rectangle plus area of this triangle. What is that? Half into base is 10 into, what is the height? Height means this part. We are calculating up to this. How much is this part? 8 minus 2, 6. Clear? Yeah. Now you simplify this. 20 plus 30. Yes or no? So then what is that, Nana? Distance traveled is 50 meters. Clear? Now third one is what? Displacement. Okay, this is also how you get area of VT graph only, na? Yes or no? Here also displacement is nothing but area of the rectangle plus area of the triangle. Okay, so that also will be 50 meters. Understood? So in this way one can find out whatever the questions they asked. Clear, Nana? Right, now let us see one more question before going to class. So that question is, see that, so there is a position time graph is given. What is given? Position time graph. Okay, now the shape of the graph looks like this. This is position x and time t. Time is in seconds and position is given in meters. Okay, no. Now it is given 2.5, right? 5, 7.5, right? 10, okay, 12.5 and 15, up to 15. On position, two things are given. One is 50 and another one is 100. 50 meters, 100 meters. Now the shape of the graph is this. Okay, the shape of the graph is this. Observe carefully. This is the shape of the graph, right? Now from this what we need to calculate is, first one, okay, average velocity. What we need to calculate? Average velocity during 0 to 10 seconds. That's the first question. 0 to 10 seconds, what is the average velocity we need to calculate? And second one is instantaneous velocity. Okay, from where to where? Instantaneous velocity at 2 seconds, comma 5 seconds, comma 8 seconds and 12 seconds. At this time we need to calculate instantaneous. Instantaneous means at a particular time, right? At 2 seconds what is the velocity? 5 seconds, 8 seconds, in this one, right? And this is the question. Now come on. So this is a position time graph, right? How do you get velocity, average velocity? We know that. What do you need to calculate? Slope or area? Very good, slope. Okay, so slope of ST graph gives what, Nana? Velocity, right? That is equal to, from where to where? 0 to 10 seconds. This is 0, 10 seconds. Okay, means up to this point. Clear? And now it is nothing but y2 minus y1 by x2 minus x1. Yes or no? Yeah. At 10 seconds what is the value on y-axis? 100 minus at y1 0. Yes or no? By x2 means at 10 seconds minus x1 is 0. How much is this? 100 by 10. 100 by 10 is nothing but what, Nana? 10 meters per second is the velocity, average velocity during this time. Clear? Yeah. Next one, what? Instantaneous velocity at 2 seconds, 5 seconds, 8 seconds, 12 seconds. Here you observe carefully the graph. At 2 seconds we don't know the velocity. The graph is given up to 2.5. Yes or no? And 2.5 to 7.5, 7.5 to 10, 10 to 15. But he asked what is the velocity at 2 seconds. So here the body moves from 0 to 2.5 seconds with a constant speed. This graph indicates that straight line passing through origin indicates that it has a constant speed, means at any point its speed is same. Understood? So you calculate speed 0 to 2.5 second. That will be the speed at any interval, means at 1 second, 2 second, whatever it may be, the speed is same. Got my point? Okay, so 0 to 2.5 seconds, its speed is same. The graph indicates that its speed is same. So that you calculate the speed from 0 to 2.5, that will be the speed at any point, at any time. Right, at 2 seconds you calculate first. Okay, how do you calculate that? Yeah, y2 minus y1 by x2 minus x1. Yes, is 50 minus 0 by 2.5 minus 0. How much is this? Yeah, very good. 20 meters per second. Okay, Nana. At 2 seconds, what is the speed of the body? Velocity of the body? 20 meters per second. What about at 1 second? At 1 second also 20 meters per second. Okay, 0 to 2.5, this is the instantaneous. Okay, at 1.25 seconds, at 2.25 seconds, everything is same because it is a uniform motion till that. I think you got my point. Next, at 5 seconds, what is that? See, at 5 seconds, the graph represents 2.5 to 7.5. It's a horizontal, parallel to time axis. What does it mean? The body is taking rest. Okay, then what is the velocity? 0. Not only that, 3 second, 3.5, 4 second, 5 second, 5.5, 6, 6.5, 7, 7 point, or till 7.5, it is at rest. Clear? Next, at 8 second. At 8 seconds. Now see, 8 means somewhere here. Yes or no? See, observe carefully, 7.5 to 10 seconds, the body is in uniform motion. The shape of the graph represents to us what information does it tell? It tells that the body moves with constant velocity from 7.5 to 10. Means at any point its velocity is same. Now calculate from 7.5 to 10 what is the velocity. So how? y2 minus y1 by x2 minus x1. So 100 minus 50 divided by 10 minus 7.5, that is 2.5. How much is the answer, sir? Yes, again what? 20 meters per second. Okay, now that means at 8 second, at 9 second, at 9.5 second, at 10 second, what is that? Yeah, very good. Now at 12 seconds, what? At 12 seconds, this is 12.5. 12 seconds means somewhere here. Now what is the thing? From 10 to 15, it moves with the same velocity. The velocity is decreasing. Okay, it represents that decreasing velocity, it represents that increasing velocity. Now it is decreasing the velocity. Now 10 to 15, with the same velocity it is decreasing. So I calculate from 10 to 15. So that how? So at 12 seconds. Now y2 minus y1 by x2 minus x1. Yes or no? Then that is equal to y2. What is the y2? 15 minus y1 is 100. Sorry, 15 it is 0. On y-axis it is 0. Yes or no? Right. Now y1 is 100 divided by x2 minus x1. What is the x2 value? 15 minus x1 value 10. Okay, this is how much? Minus 100 by how much, Nana? 5. That is how much? Minus 20 meter per second. Okay, that means at any point from 10 to 15, its velocity is, instantaneous velocity is 20 meter per second. Minus indicates that the velocity is decreasing, okay, in opposite direction, right? At 10.5 seconds, what is the instantaneous velocity? Minus 20 meter per second. At 11 seconds, minus 20, okay? So at 14 seconds, minus. Clear na? In this way one can solve it. Next, let us see one more thing before going to the session. These are some important numericals. By solving these, you can solve any kind of problems. So here, velocity time graph is given again. Okay, see this carefully. That is a velocity time graph. Time is taken on x-axis in seconds, and velocity in meter per second it is taken. Okay, now it is given as a, here it is 5 meter per second, and here it is minus 5 meter per second. Now it is 0. Okay, no. Next 10, 20, 30 and 40. The shape of the graph is given like this. Okay, this is the graph. Clear? Very good. Now what we need to calculate from this graph? From this graph we need to calculate average velocity during the period. What do we need to calculate? Average velocity. Okay na? So we know that average velocity is nothing but what? Displacement by time. Yes or no? Yes. So average velocity is nothing but displacement by time taken. It is average velocity we need to calculate from 0 to 40 seconds. 0 to 40 seconds. Right, first calculate displacement. Okay, now how do you get displacement? It's a velocity time graph. Okay, how do you get displacement? Yes, I need to calculate area. Area of VT graph gives what, sir? Displacement. Okay, and now see this, that is equal to, it's a triangle, so that half into what is the base? 20 minus 0, that is 20, into what is the height? What is the height? 5. Okay, next plus this triangle area, half into what is the base? 40 minus 20, 20 into what is the time? Sorry, velocity? Minus 5. Okay, we are calculating displacement, that's why it is minus 5. Okay, so next, because it is a vector quantity, if you take here distance, then this will be plus, sir. Remember that whenever you are dealing with vectors, be careful. So this is how much? 50, right? Minus this is also 50. So how much is the displacement? 0. What is the displacement in this case? 0. Then what is the average velocity? 0. What is the average velocity? 0. Clear this one? Yeah, in this way you can solve a lot many numericals. Now today what we are going to learn is we are going to plot corresponding graphs. For example, if you have velocity distance time graph, what could be the corresponding velocity time graph? Let us see here. Okay, now let us see one by one. First let us see ST graphs. ST graph. What will be its corresponding VT graph? Let us see that. So first one is graph is a straight line passing through origin. Graph is a straight line passing through origin. This is the graph. First tell me what does it represents? Already we discussed. It represents that the body is moving with uniform velocity or uniform motion. Yes or no? Uniform motion. Already we discussed. Now for this graph I need to plot velocity time graph. Clear? Then see this time velocity. Here uniform motion means the velocity is constant, means sorry, speed is constant. Okay, that means the magnitude of speed is somewhere. So this will be the graph. Okay, yes or no? See somewhere here, as the time is increasing but the speed of the body is constant, it's 2 meters per second, like that. Yes or no? This is the corresponding VT graph for ST graph. Understood? These are very important, Nana. You listen carefully, you pause the video and try to learn it, or else you see once again the video. Right, now the second one is what? Second one, ST graph is this, for example. ST graph. The shape of ST graph is a curve. Right? Okay. What does it mean? It means that the body has acceleration. Already we learnt. Yes or no? Now the body has an acceleration with initial velocity 0. With initial velocity 0. It is starting from rest. It is starting from rest. So you can apply s is equal to ut plus half at square. Then you will get s is equal to what, sir? Half at square only. Half at square only, because u is 0. See, from this, s is proportional to t square. S is proportional to t square. Here, what do you get here? S is equal to distance equal to speed in time. S is proportional to t. When s is proportional to t, the graph is a straight line. When s is proportional to t square, the graph is a curve, parabola. Do you understand the difference between that? When s is proportional to t, when s is proportional to t square, y is equal to x square, y is equal to x, like that. Okay, now let us see the corresponding what, Nana? Velocity time graph. So the velocity time graph looks like this. Already we learned, you can easily draw it. So it is uniformly accelerating, so that this will be the velocity time graph. Yes or no? Yeah, very good. Clear? Very good. Now let us see third one. What could be the corresponding acceleration time graph for this? Can you guess it, Nana? What could be the acceleration time graph? Here acceleration is constant. Yes or no? So that means, what is that? Yeah, this is the corresponding AT graph for VT graph, corresponding AT graph. Got my point? Yes. Next one, third one, see that? ST graph. Okay, now the ST graph is like this. What is the difference between second one and third one? Here initial velocity is 0, here initial velocity is not equal to 0, because it has some initial displacement. Okay, na? So it is not starting exactly at the origin. So here equation is what? S is equal to ut plus half at square. Got my point? Yeah. Now how can I draw this in VT graph, Nana? VT graph. Right, how to plot it? Now it has some initial velocity. Here the initial velocity is 0, so that we start from the origin. Now it starts from somewhere here. That's it. Okay, so this is. Next, coming to fourth one. Let us see fourth. ST graph. The ST graph is looks like this. Okay, then what does it mean? It means that the body has initial displacement and initial velocity. Okay, then the VT graph looks like this. Same. Okay, yeah. Next, see fifth one. Now the graph is this. See, this is This is important also. Okay, if the graph is parabola in the upward, okay na, upward, this is acceleration is positive. Now the graph is downward curve, okay na, curve is downward, then what does it mean? It means that the velocity of the body is decreasing. The velocity of the body is decreasing, okay na, so that the motion is retardation. We can say that the motion is retardation, so that this is the graph, okay na. So the graph is this, the velocity is decreasing. So here acceleration is negative, that means it is a retardation. The motion is retardation. See the difference between acceleration and retardation. So this is accelerated motion if the graph is upward, curved graph. Okay, if the graph is downward, this is retardation. Clear? Yeah. Next one is, and see that sixth one. Okay, so VT graph, sorry, ST graph. Yeah, so this is, see, both the curves are involved in this, upward and downward. Okay, up to some time t0 it has a downward, and this one. What does it mean? Okay, the corresponding VT graph is this. Yeah, this is that. Okay, this is first the body is uniformly retarded, then accelerated in opposite direction. Okay, first retarded, then accelerated in opposite direction. First, what is that, sir? Uniform retarded, then accelerated in opposite direction. Okay, so let us see one example for this. A car is retarding. Okay, a car starts from here, coming from somewhere, and brakes are applied here so that it comes to rest and again starts in the opposite direction with an acceleration. Okay, this is the graph for this. So another example also I can tell for this. When you throw a stone upward direction, what happens? While it is moving up, its velocity decreases, means the speed decreases. After a certain time, its speed becomes 0. Again it's coming down with an acceleration. Okay, so then the graph will be this VT graph and ST graph. Okay, for a vertically projected body, ST graph and VT graphs are these. First, uniformly retardation, then uniformly acceleration in opposite direction. Clear, sir? So these are the very important graphs regarding ST and VT graphs. Clear? So these are the things you need to learn in this. More things in part 3 we will discuss about graphs. Thank you very much.